So the learning target for chapter 5 here, the first learning target, is I can create a table of equivalent ratios and then find the missing values. So the first part is very easy. I mean, you're going to see here in a minute, this first page is going to seem kind of silly in a way. But it's important going on to learning target number 2, and then it's going to be important going on to algebra someday, okay, when you guys go to algebra in either 8th or 9th grade. Okay? So the second part's really important, but we'll get to that when we get to that. So basically, what a ratio table is, it's just a table that's showing equivalent ratios, right? So as you can see right here, the ratio that was given was for every 1 soda, there are 3 juices. Right, guys? So what am I doing to 1 to go to 2? So did we do that to go to 6? What did I do to go from 1 to 3?
Multiplied by 3.
Did we do that?
Yes.
Yeah, exactly. I mean, that's all it is, but it's organizing them into a table. Now, that seems silly, and some of you are like, well, why on earth are we doing that? I don't really understand why it's too necessary. Well, here's where we're going. Now, you don't have to write this, just kind of watch. This is where it's going. Okay? As we go in here, you're not going to be given a table like this. You're going to be asked to find out.
An interruption. Garrett Pasqualone, please come to the main office. Garrett Pasqualone, please come to the main office. Thank you.
Okay? You guys are going to be asked here to find, okay, what's that and what's that? If I need 27 juices, how many sodas is that? If I need 27 sodas, how many juices is that? And you use all the same things you learned in chapter 4 and in the knowledge you have about equivalent ratios, and you just apply them here. What am I doing to go from 9 to 27? Luke?
Times 3.
So what do I got to do to the 3 then? Brooke? So isn't that going to be 9? Right, guys? And then then we can go here and we can do the same thing. What am I doing to go from 3 to 27?
Multiplying by 6.
Timesing it by 9.
My fault.
Okay? So what do I got to do to 9 then?
Multiplied by.
Multiply by 9. So that's how we can find missing values. So that's where that part of the learning target comes into play. We're making these tables, and then we are finding missing values at the same time. Now, I'm going to fast forward here to learning target number 2. You're going to be able to plot pairs of ratios. So basically, you're going to be given something like this right here. Doesn't that look the same right there as what we just did, pretty much? It's vertical instead of horizontal, but it's the same thing, right? But then we're going to call these our x's and these our y's, and then we're actually going to graph these. So do you kind of see why we're putting them into tables? Okay, this is basically a function table. This relates back to function tables or in and out tables, whatever you've called them in the past. Okay? All right, so let's get back to the front page here. Let's go down to this one here. Okay? To make yellow icing, you mix 6 drops of yellow food coloring with 1 cup of icing. Guys, what is that right there? Fake ratio, exactly. Now, every time you're given a fake ratio or a ratio, you should come up here and actually write it like this. Now, I'm going to show you 2 ways here, so I need you to be writing this. Okay, if I'm writing it, you're writing it. I'm not going to ask you to write that much. Okay? Now, because I know I can set this into a proportion, I know that I'm either going to be given a certain number of yellow drops and be asked, how much white icing will I need? Or I'm going to be given a certain number of white icing or cups of white icing and be asked, well then, how many drops of yellow food coloring do I need to use? Right? And that's exactly what it does. How much yellow food coloring, so we're trying to figure this out, right? Should you mix with 5 cups of white icing? Okay, so I'm showing it as a proportion up here. What did I do to my cups of white icing? Creaky? So what do I got to do to my drops of yellow food coloring? And what are we going to get? 30. You guys all see that? Now, as you guys look at the proportion there, is there really any difference between that and that ratio table?
No.
It's the same thing, isn't it? It's the exact same thing. That's what I'm trying to tell you. So the beginning stages of this learning target are kind of like, I don't really understand. Like, it's the same thing. Why are we doing something different? Well, I showed you. Learning target 2, that's going to become the 0.61. That's going to become the 0.35. 30 comma 5, that is. Okay? Now, this is where we actually got to get into something a little bit more tricky. So this is where the skill, this is why I really like this chapter, what I'm about to show you right here. Okay? In a recent year, Joey Chestnut, my hero, won a hot dog eating contest by eating nearly 66 hot dogs, gross, in 12 minutes. Even grosser. Okay? Now, what did I just put brackets around? My ratio. So everybody go down to the bottom here and write this. Okay? Now again, I know that I can set up a proportion here, and I'm either going to be given a number of hot dogs and be asked in how long would it take him to finish them, or I'm going to be given an amount of time and ask, well, how many hot dogs did he eat in that time? So let's keep reading. If he ate at a constant rate, determine about how many hot dogs he ate every 2 minutes. So right there is our real part. Remember, this is my ratio over here. This is my real ratio over here. Okay? Row ratio. All right, so we know nothing. Never mind. All right. So what did I do to my number of minutes? Crinkles? So what do I got to do to my number of hot dogs then? That's going to be 11 hot dogs. Now, do you agree that that's correct?
Yeah.
Now, let me show you what they did. Now, this is interesting because they used something, and I would like everybody to write this, please. They did something called scaling, or kind of scaling. They didn't really use scaling the right way, but they did. So everybody write the word scaling down there in the right somewhere, bottom right.
They didn't do a great thing.
Well, they didn't really. You'll see what I mean here in a little bit. Because what we did is we realized, now I want to make this clear, we didn't know all this, right? All we knew was that. And that's what you're going to be given on the test. Okay, did everybody see that? I'm going to give you this table right here, and I'm going to say, I want to know that. You guys get me?
Yep.
Now this one's easy because you don't really need to do 2 steps. You could say, well, I'm dividing by 6, right guys? But you can see what they did. They said, oh, they're both even, so maybe they didn't know their math facts very well, or maybe they just felt like scaling it for some reason. They divided by 2, and they got 33 over 6. Right? And then, what are you doing to go from 6 to 2? So then you've got to do that to 33 also, and that's where we got 11. So that's all great. I mean, that's an easy question. As you can see, we did it with the proportion and got the same answer. Basically, it was a proportion. Now, do you guys got more room at the bottom somewhere?
Yeah.
Okay, here's what I want everybody to do. Actually, we're going to do it together, and then you'll do one on your own here in a minute. I'm going to erase this for just a moment. Okay? And what I'm going to do, I would like you all to write. Actually, you know what? Let's just draw it together. So I'm going to draw this box right there. Okay? And then I'm going to need three lines in between. So making 4 groups. All right? Chill, bro. All right, so these are my hot dogs. This is my minutes right here. Everybody agree with that? Now, the fake ratio is still going to stay the same. He ate 66 hot dogs in 12 minutes. Everybody cool with that? All right. So, but I'm going to change the question. I'm going to say I want to know how many hot dogs he ate in 8 minutes. So that means this is going to go here. Now, I'm going to show it as a proportion, just so please don't work ahead. Just stay with me. So this is where scaling really is going to be very important. What's up? It's going to be very, very, very... Shh. All right. Here's where scaling is going to be a little bit more important. This is actually a really good skill. This is something I'm going to refer to a lot, pretty much for the rest of the year. Scaling. Okay? Now, as you look at this proportion, is there any way to go from 12 to 8? Do you guys know what you're dividing by? Now, is it a decimal? Sure it is. But do we ever want to really mess with decimals? Remember, the one thing about decimals is sometimes when they go on forever, Aiden, you with me? Sometimes when they go on and on forever, or they just there are a lot of numbers. We lose numbers, or you don't get the whole value of it though, right? Sometimes decimals don't allow us to show the whole entire value. Is everybody understanding on that? Okay, so we don't know. So this is where we're going to use a method called scaling. Now, I'm going to explain this two ways. The first way, what scaling is it's saying I need to go from this number and I need to scale to some number that I know would not only be able to become that from 12, but then it would also become 8. What do you call a number like that? What do you call a number that would be able to be divided by, be able to divide 12 evenly and 8 evenly? Brussels sprouts?
Common factor.
Absolutely. So over there where you wrote, you should have written scaling somewhere. I'd like you to please write common factor. Everybody got that? So you want to use a common factor. That makes sense, right? Factors are things that are numbers that divide numbers evenly, right? So what would be a common factor that we could use here, Mega?
4.
4 would be perfect. Could we also use 2?
Sure.
Absolutely. I hope you guys are all hearing this and writing this. So now I'm ready to roll. What am I doing to go from 12 to 4, Evan? Dividing by 3. So what do I need to do to 66? Yep. Divided by 3. Which is?
22.
22. Everybody agree with that? So now I'm ready to go to the next thing. Now I'm trying to figure out this, remember. That's the whole goal here. I'll highlight it so you guys get what I'm saying. That's what we're trying to figure out. How many he can eat in 8 minutes. What am I doing to go from 4 to 8? Creakies? So what do I need to do to 22? And we get 44. Is that making sense, guys?
Yeah.
That's scaling. Do you see how scaling can be important? When you're faced with a situation like this, when you don't know 12 times, or 12 divided by what is 8? We don't know that. None of you do. You could probably figure it out, but then you start getting decimals involved and all kinds of stuff. Repeating decimals, that's where things get challenging and you end up not getting the exact answer. Yes?
Well, would you just like turn 12 over 8 into a fraction and simplify it and then
12 over 8.
I mean sorry, like
That is what it is. That is what you're dividing by, but we're trying to take decimals out of the equation.
right when you would divide both by 4 and and get 2/3 and then just by 2/3.
You get 3 over 2.
Yeah.
Well, but that's what I'm telling you. We could have also used 2 here. Let me show you what I mean, because I feel like you're not. Okay, I don't want you to get confused. We could have used also. I mean, you're right. You're absolutely correct. Again, I'll set this up again. We got hot dogs. We got minutes. And we got 12, and then we got 8 there. What you're saying is turn this into 2. Right?
Then you should turn it a fraction and simplify it and then
Oh, I see what you're saying. Well, I don't know what that would work, but what if you didn't simplify to get something that would become 8? Like, what if you simplified it and you end up getting 3 to 5? Can 5 become 8?
No.
Never mind. Okay, let's just keep working. You'll see. It'll all click. So let me show you. You can also use 2 here. So what am I doing to go from 12 to 2? Divided by 6. So I could do that here. That'd be 11, right? What am I doing? Times 4. Times 4. See, it doesn't matter. We still get 44 no matter what. Now, one more thing. You don't always have to use the common factor. Does anybody want to guess what else you could use? You could use the LCM. Exactly. Because they're all related. So here we go. Hot dogs. I hope you're writing all these down. To minutes. Okay, we know it's 66 to 12 and 8 there. So now, does anybody know what the least common multiple of 12 and 8 is? Think about the multiples of 12. Remember, you always think about the multiples of the bigger number. So let's think. 12. Can 8 become 12, guys?
No.
Okay,
Yeah.
12, 24. Can 8 become 24?
Yes.
There's my LCM. Okay, so here we go. what am I doing to go from 12 to 24?
Multiplying by
So what do I have to do to 66 then?
multiply by
And I'm going to get 132, right? Now, what am I doing to go from 24 to 8? So what can I do to 132?
divide by 3.
Whoops. And that's going to be 44. But what I'm trying to show you, the general theme here is you can use a common factor. You can use a common factor. You can use a common factor to scale or a common multiple. It really doesn't matter. So everybody write that under scaling. Everybody see that? Understand that? Those are your three things, or the two things you can use. You can use any common factor. You can use any common multiple. The only common factor you don't always want to use is 1, because then you're going to get into decimals. Okay, now you can do it. I mean, you can get into decimals, but like I said, decimals don't always tell the whole story. Go to the next page. Okay? We can't show 0.3 repeating. Okay, here we go. Cans of corn are on sale for $4, right? What is that, guys?
Fake ratio.
That's your ratio. That's your fake ratio. Okay, and that's going to be for $4. Okay, and then we know that we want to find out how much 15 cans cost. Now, does anybody know what we're multiplying by to go from 10 to 15? It's 1.5, but again, we don't want to mess with decimals, right? Right, guys?
Yeah.
So this is where we're going to scale. So we're going to go to this box right here, and we're going to say, okay, what is a common factor that we could go to and then be able to go back to 15? Erica?
Divide by 3.
Now hold on. I don't want to know what you're dividing by. I just want to know what the factor is. What do we want to figure out how many cans of corn? Trussell? 5. Do you guys all see that? So what am I doing to go from 10 to 5?
Divide by 2.
So what do I got to do to 4?
Divide by 2.
Okay, and then you get 2. What am I doing to go from 5 to 15?
Multiply by 3.
So what do I got to do here?
Multiply by 3.
It's going to be 6. Did you guys see how I did that? That's scaling. Now, don't ever get confused on where to scale. I get some people that say, I need to scale something to here. Well, that doesn't make any sense because you don't know what this is, right? Right, guys?
Right.
Like this we don't know. You can only scale when you know 2 pieces of the information. Now, we did a common factor. We used 5. What else could we scale to, though? By the way, I didn't mention this. Scaling backwards means finding a common factor. Scaling forward means finding a common multiple. What common multiple do they share, Ethan?
20.
20 is not a multiple of 15.
Oh. 30.
30. So, what did I do to go from 10 to 30?
Multiply by 3.
So, what do I got to do to 4?
Multiply by 3.
So, what did I do to go from 30 to 15?
Divide by 2.
Did I get the same answer?
Yes.
All you're doing is creating equivalent ratios. Does that make sense? It's the same thing. Okay? Now, why is this important? I don't expect you guys to make a table every time we're going to do these. Now, in this chapter, I do. If I ask you to, if it's learning target 1, yes, you have to make a table. But what I'm trying to prepare you guys for is when you're given a ratio like this, I can scale this thing. And I can say, I'm going to scale it back to 5 cans. That would be 5 to 2, right? Now I can do that and figure out that $6 is the cost for 4 cans. Or I'm sorry, $6 is the cost for 15 cans. Everybody agree with that?
Yep.
Yeah.
Okay. And you can see that's what they did there. They scaled backwards. Okay, if I said, this one right here, if I said 8 to 14, and I said, okay, if that was the proportion I gave you, think about this from, hold on, real quick here. You guys can write that one, but you don't have to write the one I'm about to write. On the test for chapter 4, I gave you stuff like this. And you guys could easily see what you were multiplying by, right? That was basic. Now we're getting it a little bit harder. Can 14 become 49?
Yeah.
No, it cannot. So this is where we've got to use scaling things. We got to scale backwards to then be able to go forward with it. So what is a common factor of both 14 and 49? What is a factor of both 14 and 49? Frankie?
7.
7. What am I doing to go to 14 to 7?
So divide by
Divided
2.
by 2.
So what do I got to do to 8?
Divide by 2.
Would you agree that 4 to 7 is the same ratio as 8 to 14?
Yes.
Same thing. Now I can move forward to figure out this because that's the whole goal, to figure out that. What am I doing to go from 7 to 49?
Times by 7.
So what do I got to do up here?
Multiply by 7.
So I know that whatever this proportion was about, whatever this proportion was about, I know that the unknown there was 28. Now, I personally think, and I think you guys will agree, that proportions make a lot more sense when you give them labels, right?
Yeah.
It's one of those weird things in math where actually story problems make them easier a little bit, kind of.
Okay.
At least they make you understand them a little bit. Okay? So, I hope you're all, guys, go and do one more. Got about.
1, yes. Oh, no, no.
You're writing stuff. Go
Ah.
ahead and do that.
Okay, John, you said
Yes. Everybody do that real quick. Okay, so what we have to do is we've got to figure out something that I can scale to that would allow me to get evenly to it from 9, but then also be able to get to 24. So I want to find a common factor. If you want to use the greatest common factor, that makes it even better. But this one, what's a common factor, Mega?
3.
You guys agree with that?
Yeah.
3. So now we can break it down and say, okay, what am I doing to go from 9 to 3?
Divided by 3.
So what do I need to do to 6?
Divided by 3.
So all I'm doing is creating equivalent ratios, right guys?
Yeah.
What am I doing to go from 3 to 24 now? Ethan?
Multiply by 8.
So what do I got to do to 2?
Multiply by 8.
Do you guys see the value and the importance of being able to scale now? It really is a good thing because there's no way to do it, well there is, but I'm not going to show you how yet, of doing it without scaling in that situation. Okay?
People are waiting at your door.
They can chill, homie.